Hello guys, in this video we are going to start talking about conservative vector fields, and in this question we have a vector field that has two components. We want to see if it's conservative, and if it is conservative then we will be able to find something called its potential. Okay, so the first thing you do is just take the partial derivative of the first component with respect to y, because this only has two components, so the check is pretty easy. Which will become 14x, because we treat 14 and x as numbers. And then partial with respect to y of 6y would just be 6. And of course, the negative 6 becomes 0. Now, if we do the same thing with the second component with respect to x now, we will get 14x plus 6. As you can see, both of these are the same, which tells us that this force is conservative. Once we determine that, we are going to check out is see if we can find a potential function. But what's that mean? Basically, what that means is that there exists some function of two variables, okay, such that if we take the partial derivative of it with respect to x, we will get the first component of the force. So this whole thing is a partial derivative of something with respect to x. And then this whole thing is a partial derivative of the same something, but now with respect to y. How would I find that function? By the way, it is not unique, because as with derivatives, you know that derivative of a number is 0. But generally speaking, you don't have to add plus c, because you just have to find a potential function. So we'll just take the one that's simplest one. All right, so what do we do? First of all, we have to integrate the first component, because we're trying to undo the derivative with respect to x by taking the integral with respect to x instead. So to try to undo the derivative. So this is what we're doing. We're doing dx, okay? So let's see, we'll come back to this question, but first let's see if we can try to solve it. Okay, what happens when you take the integral of 14 xy with respect to x? Now, I highlighted 14 and y because both of them are numbers if you take an integral with respect to x. We keep 14y, and then x becomes x squared over 2 when you integrate. Okay, plus 6y. We take again the integral with respect to x, but think of 6 and y as just numbers, so this will just be 6yx. And then finally minus 6x, because 6 is just a number by itself. All right, so we have a whole bunch of stuff here, a lot of terms, but it is possible that we're still missing a term. And maybe that term has y in it. Why is that the case? Well, because when you are anti-differentiating, you have to add that plus c. And normally when you only had one variable, that plus c would just be a number. But because here you are integrating with respect to x while treating y as a number, this constant of integration might have y in it. Might or might not. Well, we'll have to figure that out. So how do we figure that out? Well, we look at the second component, because remember, we only used the first component so far. And if we, again, integrate now the second component, and with respect to y, we are supposed to get the same answer. Okay, so let's see what happens. Now, by the way, 14 and 2, that's just 7. If I take 7x squared and integrate that with respect to y, that becomes 7x squared y. Why is that? Again, because 7x squared is just a number. So integral of a number would be number y. Okay? Now, 6x is also just a number. So that will become also 6xy. And again, just like before, we might get something else that only has y. Now we want to compare these two answers and match them. The first thing I want you to focus on is all what we call mixed terms. A mixed term should have at least two variables. So in the case of only two variables, then you will have a mixed term that has x and y. Mixed terms must be the same, otherwise these two things cannot possibly be equal. Which means that if I'm looking over here at 6yx, this is the same as 6xy. Check, that's good. Then I'm looking over here at 7yx squared and also 7yx squared over here. If you just switch order, you can see that this term matches this term. So all mixed terms have to match. If they're not, that means that your check of conservative vector field was just incorrect. Okay, and then I made a mistake over here. This constant, because we were integrating with respect to y, actually has an x. Okay, so now that's correct. So if we compare these two, we don't have anything that has only y in the second integration. So that part we can assume is 0. But we do have this guy, and that is really just that of the one we couldn't find, that C2 of x, that is really just negative 6x. So now let us combine all of that into one potential function. So it'll become 7x squared y plus 6xy minus 6x. Now, to check your work, I always recommend checking your work. What you should do is take this answer, which is the potential, take the partial of that with respect to x. Are you going to get 14xy plus 6y minus 6? Yes, great. Now take the partial of this thing with respect to y. Are you going to get 7x squared plus 6x? Yes, check. So that means this is a potential. So I am correct. Okay, just make sure that you never use mixed term more than once. So like if it's 7x squared y occurs twice, which it should happen, that doesn't mean that you're going to multiply it by 2 or something, because these two things, it should just be equal. Okay, so let me see if I can put that in here. And then I had, I believe there was one other term that I cannot see right now, and that is minus 6x. Okay, so now that we found the potential, how are we going to find work of a force, this is the force field, to move a particle from a point with coordinates 0, 1 to a point with coordinates 4, negative 3? How are we going to do that? Well, the first thing we're going to do is substitute the start of the path. So this is start of the path, and then this is the end of the path. We're going to substitute that into the potential. We're not going to integrate, even though it looks like you're supposed to integrate. But no, there is a way to compute work without integrating if the force is conservative. So how do you do that? Well, take your potential, plug in, first plug in the ending point. So I'm going to plug in 4, negative 3 first. Okay. Now, because I have this wonderful calculator, which I am going to just use right now, so I don't have to think. So this is 7x squared y plus 6xy minus 6x, I believe, right? Okay, so we want to plug in the end of the path, 4, negative 3. Oh, okay, my God. And then we also want to plug in the start of the path, and that's actually just 0. So this is negative 432, and then f of 0, 1 is 0. Now, we just, when we enter, we just want to make sure that we enter in them in correct spots. So that is actually 0, that is negative 432. So they just put them in different order. But then what you do is you take the ending value and subtract the starting value, which of course in this case is just going to be negative 432. Now, if you're wondering if work can be negative, the answer is yes. If the force is actually is in the opposite direction to the motion, it is possible that the work will be negative. But we are done here.